So did you know that if you scream at a spider, it can't hear you? If you stamped next to it, it would be able to feel those vibrations travelling through the ground. Many animals can sense vibrations through the ground, including humans. But for things like spiders, this is their primary sensory modality, and the amount of information that they can extract from that is far higher than us.
They use vibrations from their prey to help them detect where food is. So it's their main sensory input for predation. They also generate vibrations during courtship. So when males and females are trying to find each other to mate.
Working at the interface of biology and engineering means that we look at a biological animal like the spider and model it as a biomechanical system. So this enables us to give insights into how vibrations are received by the spider and what the response is to vibrations transmitted through the ground, plants, or an engineered substrate like the spider's web.
A lot of what they're doing is detecting the presence and the location of other types of animals. So they use vibrations for that, partly because it's very difficult for an animal to hide the vibration that it makes as it moves.
QPNA spiders can't see red light, and that's why we're using that to film today. So this Polytech laser vibrometer is the piece of equipment that we use to measure vibrations on the surface of the spider or the leaf that it's on. So when we focus the laser on the cuticle of the spider, that enables us to measure exactly how this cuticle moves as a vibrational wave travels through it. We can learn from millions of years of spider evolution and take inspiration from this to develop the next generation of vibration sensors. One important application of vibration sensors is understanding how structures like buildings respond to vibrations like earthquakes through the ground.
Part of the reason why we're doing this work is to understand more about spiders, but also by unpicking these mechanisms of how they're able to get this information, we might be able to find inspiration for the design of new types of sensors for robotics. So particularly how biology can inform new types of soft robots that are perhaps away from the metal robots you might think about, something that's a little bit more inspired by nature, that's making use of these embedded sensors the same way that animals do.